this problem about a plane that is heading due north at a speed of 400 miles per hour, and a wind is from the southeast at 35 miles per hour. This problem is found in the vectors lab that I've given you to work on. There are 6 questions on that vectors lab. The first one is just a basic vectors problem, no application at all, just find the resultant of 2 vectors. I believe the next one is a truck is pulling some components. 3 men are pulling an automobile with some forces indicated, and find the resultant force. So that's the worksheet that we're talking about. But the reason I want to do this one is with you by video is that the wind is coming from. From is the key word, the southeast. So I want to do this problem with you. Let's go ahead and draw a better picture of everything. So a plane is heading due north at 400 miles per hour. So let's see if I can get this thing to draw a straight line. So here's the plane in blue heading due north at 400 miles per hour. So it's at a 90-degree angle. And as a matter of fact, let's go ahead and start our table. So we've got the plane, its magnitude, and its angle. So here's the description. Plane, and its magnitude is 400 miles per hour, and its angle is 90 degrees. And then we'll be filling in the x component and the y component. And you know what? As a matter of fact, I wouldn't mind if we did that right now. So you're welcome to go ahead and type 400 times the cosine of 90. Please do. You're welcome to type 400 times the sine of 90. Please go ahead and do that. But why bother? Look at that blue line. It's not going in the x direction. It's only going in the y direction to the tune of 400 miles per hour. So when you have a vector that's on a quadrantal angle, a 90, a 180, a 270, a 0, or a 360, you don't have to do this typing on your calculators. You should be able to recognize there is no x component to the speed of the plane. There is only a y component. All right, we're going to add the wind in here next. The wind is coming from the southeast. So here's the south, here's the east. It's coming from, so this is old man wind blowing from the southeast. But it's coming from the southeast, I'm sure you're getting tired of me saying that, at a speed of 300 miles per hour. So it's going into the northwest. So when it's from here, it's going into there to the tune of 35 miles per hour. And because it says southeast exactly, we say that you're bisecting that angle, that 90-degree angle, so that this would be 45 degrees right here. And so since that's the case, in my table over here, 90 plus 45 is going to be 135 degrees for that 35 mile per hour wind. And when you take 35 times the cosine of 135, that's what's going to give you the negative sign on your x component of negative 24.7. And when you take 35 times the sine of 135, because sine is positive in the second quadrant, that's going to give you the positive 24.7. So this vector, remember, is broken into, I wish I could, I'm going to go with green, I guess. It's broken into this negative 24.7 and this positive 24.7. So finally, when you want to find the resultant, you add the x components up. So the 0 plus a negative 24 is a negative 24.7. And when you want to find the magnitude of the y component, the 400 plus the 24 is 424.7 positive. So think of it as this blue vector and this little green line getting added on top. Because remember, this is how I find my resultant here, is by putting their tails together. Let's see if this will work. And so the resultant vector here goes to this opposite corner of that parallelogram. So that's my results. So I had to take this green segment right here and add it on top of that blue segment to get to the end of this vector. And then I had to go to the left, this green amount, this 24, to get over here. So again, these two numbers right here are to get to this ordered pair right there, which means go to the left 24.7 and go up 424. And then when you have an x and y, it's always Pythagorean theorem. So we take the square root of the 24.7 squared plus the 424.9 0.7, I'm sorry. Please don't ever put this negative sign in here, because if you put it in and you don't put it in parentheses and you're not using the program, it's going to give you a negative results when it squares that number if it's not in parentheses. So you must do that. So the magnitude of the plane is that it's actually traveling 425.4 miles per hour, not 400 miles per hour. It's traveling 425. The reference angle is the inverse tangent. Remember that I just use the y value divided by the x value, and I use positive numbers. I don't use this negative sign right here to get my angle, and that angle is 86.67 degrees. But because I know this x component is negative, it's a negative number, and this y component is positive. Say I can't draw a picture very well. If x is negative and y is positive, then I'm in the second quadrant. So one of your options to state where the angle is to take 180 degrees and subtract your reference angle, which would give us 93.33 degrees. So we could state our answer in several ways. The resultant of the plane is that it travels at 425.4 miles per hour. However, we could say that it's at an angle of 93.33 degrees, but then it's not an aeronautical statement. We could also say that it's an angle of 86.67 degrees north of west. So see this red line? This right here, that's the reference angle, is 86.67 degrees. And if I go from the westerly line and go up to it, I'm going north of west. I could always use this itty-bitty angle too, which is probably about 3.33 or something like that. 3.33 degrees, and that would be west of north. So there's a lot of ways to state the size of the angle. In navigation, it's probably going to be one of these two ways. I believe it's often starts with north and south, and so it uses this approach. I hope I've helped you with some applications of vectors. Next, we'll be on to law of sines and law of cosines.